What's up guys, so in this video I'm going to show you how to make a Dogecoin version of the famous space race game, and let's get started. So the first thing you're going to want to do is open up PyCharm and create a new project. We're going to name this project Dogecoin Race. I'm going to be using Python 3.8, but any Python 3 version should work well. I'm going to go ahead and create a main.py welcome script also. So let's go ahead and create that. We're going to clear out all the auto-generated code and start from scratch. So the first thing you're going to want to do is open up the GitHub link down in the description and download the assets that you're going to find in there. Those are the assets we're going to need. There's a couple of pictures, some audio files, stuff like that. So make sure you go get that folder and you're going to drop it right here inside of the main directory. I have it in my Finder, but you're going to be able to find it on GitHub. It's called Game Assets. So I'm going to go ahead and drag that right there until it highlights the title bar in red. Press enter for refactor, and now we've got access to these four assets. The first one's an asteroid, the second one is a song that we're going to be running in the background, the third one is the rocket for the players, and the fourth one is the background image. So now that we've got those inside of our project, we are going to actually start writing the code. The first thing we have to do is import Pygame, because we will be using Pygame for this. If you don't have Pygame, that is no big deal. Just be sure to pip install Pygame inside of the terminal and you will be able to get that situated. The next thing we're going to do is also import random, because it's a game, it needs some randomization. And those are the only two import statements that we're going to need for this project. Once we have those, we're going to declare some global variables that we're going to use throughout the code itself. The first thing we need to clarify is the screen width and height. I'm going to be going with 800 by 800 for the game window. You can choose any dimensions that you like. I just feel like that's a good size for my computer. So I'm going to say screen width, or SW, equals 800. And then screen height is also going to equal 800. Next, what we're going to do is go ahead and initialize all of the assets that we just imported into the project. So the first thing we're going to do is create a variable for the background, so we'll call it BG, and we'll set it equal to pygame.image.load, and then we're going to pass in the name of the file as a string, so it's going to be in single or double quotes, and we will say game assets / space with moon.png. The second asset that we're going to load is the asteroid, so we'll call that AST for asteroid and set it equal to the same thing. So we'll say pygame.image.load, and the name of that one is going to be game assets / asteroid 28, because it's 28 by 28 pixels. The third image we need is the Doge rocket. So we'll create a variable called Doge, set it equal to the same thing. Let me just copy this and change the name to Doge rocket.png. So those are the three images we need. Next, I'm going to just go ahead and create a variable for the background music that we're going to set later on. So we'll say music equals pygame.mixer.music.load. And we'll pass in the name of that file, which is game assets / Dogecoin song.mp3. And those are the four assets that we have inside of our game assets folder. So now that we've got that taken care of, the next thing we're going to do is create a global variable for the timer of the game. So it's going to be kind of like a clock, keeping everything lined up. So we're going to say clock equals pygame.time.clock with a capital C and add some parentheses to the end of that. This is just going to come in handy later on for whenever we create the main while loop of the game. And lastly, before we start writing any classes, we're going to create the window for the game, which is going to be win for window, and we're going to set that equal to pygame.display.set_mode, and we will pass in the size of the window as a tuple. So we're going to have another pair of parentheses inside of these parentheses, and we're going to say SW for the width, and then comma SH for the height. And that's going to wrap it up for this top portion of the code. Now that we've got that taken care of, what we're going to do is create a class for the player. And so to do that, we're going to say class player with a capital P, and we're just going to pass in object for now. throw on a colon at the end, and we're going to create some functions for this class. So the first function that we're going to make is the initialization function, which is what's going to be called as soon as we create an instance of a player, which we're going to do twice because this is a 2-player game. And to do that, we're going to say def for define space underscore underscore init, and we're going to pass in 2 other variables inside of these parentheses that we are going to be using. Actually, we're just going to pass in one, which is going to be the x position, because the 2 players are going to have different x's. And since we passed in the x, now we're going to say self.x equals x, so now we can have access to it from anywhere else inside of this class. And we're also going to create a y position for the player, so we'll say self.y, and we're going to set the y equal to around, I'd say 650, because it's 0 is the top and we want it to start off at around 650 from the top, so it's going to be closer to the bottom. But instead of just hard coding that in here, I'm going to go up here and I'm going to create a variable called like OGY, we'll give it like a capital Y, and we'll set that equal to 650 so that later on in the code we can, if we want to mess with that, we can just change it here once instead of changing it multiple places. And so here we'll say equals OG capital Y. The next thing we're going to do is create a width. So we'll say self.w is going to equal 50 pixels, and then self.h for the height is going to equal 100 pixels. The player is also going to have a velocity because it's going to be moving up and down the screen. So we'll say self.yv for y velocity. We'll set that equal to 0 by default because the player should not be moving upon the running of the code. And then we're going to give each player an image, which is going to be equal to the Doge image that we loaded up here recently. The last thing we're going to create in here is a variable to keep track of the player's score, so we'll set that equal to 0 by default. That's going to wrap it up for the initialization function. The next method that we have to create is going to be the draw method, which we're going to call every single frame of the game to display the character on the screen. So we'll say def, and then we'll name it draw. And then in here we'll pass in one other variable called window. And to display the image of the character on the screen, we're going to say win.blit self.image, comma, and then the x and y position in another pair of parentheses because it is a tuple. So we'll say self.x, comma, self.y. And that's going to be it for the draw method. And we're going to create one more method for now, and we'll have another one later. But this one's going to be update the speed, because whenever the y velocity is not 0, the player should be moving. So what we're going to do is we'll say define update underscore speed. And in here, all we're going to do is just say self.y is going to plus equals self.yv. So that's going to wrap it up for now for the player class. And just so we can be on the same page and understand what we just did, I'm going to go ahead and create a player outside of the class. So as you can see, I'm going to unindent so that this code is no longer associated with the player class. And what we're going to do in here is we're just going to say like P1 for player 1, and we'll set that equal to a new player, and we can choose any x that we want. I think I'm going to set him equal to 175. And now if I run it, we actually won't see anything because we aren't calling the draw, but we can just say P1.draw. We'll pass in the global variable window from up above. And I believe if we run this now, we will obviously get an error because that's how life goes. It says mixer is not initialized on line 12. Let me go ahead and see what that's about. So I think we have to actually we actually have to start playing the music. So what we're going to do is type in pygame.mixer.music.play, and we're going to pass in a -1 so it'll just loop it once it reaches the end, which doesn't solve our problem. Let's just go ahead and comment out the music for now. So if you just highlight them and then press Command / or Control / if you're on Windows, it'll comment those 2 lines. We'll worry about that when we get to it. Let's go ahead and run the code. And we don't get anything because we have not called pygame.init, of course. So let me go to the very, very top, right under the import statements, and type in pygame.init with 2 parentheses. Now let's run this one more time. and we we still don't get anything. And the reason for that is that we are not actually displaying anything. So the way we can actually see what we've done is we're going to go ahead and create a function. Let me go up above these two lines where we created the player and we draw the player. Let me get rid of the draw right here, and what we're going to do is create a function that's not inside any class, and this function is going to be called redraw game window. So what we're going to do in here is we'll say def redraw game window. We don't pass it anything, and what we're going to do is call win.blitz, and then the background image and the x and y coordinates of the top left of it, which is going to be 0, 0. So we're passing another pair of parentheses to make it a tuple and say 0, 0. And then in here is where we're actually going to be calling all the draw methods of every single object that we have on the screen. So we can go in here and say p1.draw, and we'll pass in the window. And let me just go ahead and create player 2 just so we can have both of them already prepared. So we'll say p2 equals player, and we'll give player 2 an x coordinate of 575, and then we'll call p2.draw, and we'll pass in the window. And then at the very end of the redraw game window, all we need to have is a line that says pygame.display.update, so that it'll basically clear the display and then update it with all the changes every single time this function gets called, which as of right now we're not calling it, but we will be very, very soon. Before we see all our changes, let me just go ahead and create the main while loop of the project. So to do that, I'm going to create a variable called run. We'll set it equal to true because as soon as we press run, we want our project to be running. And then what I'm going to do is say while run, we want to call clock.tick to update the game. And then the number we pass in here is kind of like a frame rate. So I think a good rate for this game is going to be 100. So I'm going to type in clock.tick, and we'll pass in a value of 100. Another thing that we're going to have to do inside of this while loop, which I usually just keep at the very end, is calling this redraw game window function. So we'll say redraw game window. And now I believe if I press run, we don't get anything yet, but I feel like we're getting there. We're getting very, very close. So before I try one more time, let me go ahead and run to the very bottom of the code, type in pygame.quit, because once we reach this point, that means we're no longer running. We want to break out of this while loop. And another piece of like boilerplate code that we need to have inside of this while loop is going to be a for loop that checks if we are trying to exit the game. So what we're going to do is we're going to say for event in pygame.event.get, throw a colon there. We're going to say if the event type, so event.type, is equal to pygame.quit, which basically means the user clicked the X at the top left or right corner. And then what we need to do is change run to false, because that means the user no longer wants to play. And now let me try running and just seeing if we've made any progress. So run, and as you can see, we have finally gotten our background image displayed, and here is player 1, and on to the right is player 2. They don't move just yet, but we're going to be adding the functionality for them to start moving up and down the screen, and then afterwards we will start adding the asteroids as obstacles that would be coming from the right and left side. So I'm going to close this window, and let's go ahead and add the player movement controls for this game. So to do that, what we're going to need to do is inside of this for loop, we're going to add a couple more if statements. The first one is going to be checking to see if the user has pushed any of the keyboard keys down. To do that, we're going to type in if event.type is equal to pygame dot, and then in all caps, key down. Then we're going to check what key they pressed down. So we'll say if the event.key is equal to Pygame dot k underscore down, also in all caps. So basically, if the players press down the down arrow key, well, that means we want the player 2 sprite to move down. And to do that, we're going to say p2 dot yv, so player 2's y velocity is going to be set equal to a negative value so the player can start moving, or it's going to be set equal to a positive value so it can actually move down the screen. Because as we increment the y, it's going to be moving down, and as we decrement the y, it will be moving up. So before we do this, I'm going to just scroll to the very top, and similar to how we have OGY, I'm going to set just a constant speed variable so that if we don't like the speed, we can just mess with it here instead of messing with it in every single place we have it written down. So we'll say speed equals, let's say 2, we might change it to 3 later on if we feel like that's too slow. And here we'll say player 2's y velocity is going to equal the speed. Hopefully that makes sense. And now, similar to checking for the down arrow, we're going to also be checking for the up arrow. So I'm going to copy this if statement, paste it right here. I suppose we can just, well, let's keep it as 2 if statements. And then we'll say k underscore up instead. And if that's the case, we're going to be setting the y velocity equal to -1 times the speed. So these are the controls for player 2. And now the buttons that are going to be used for player 1 are going to be the W and S keys. So to do that, we are going to have 2 more if statements. So we can just go ahead and copy these 2 lines, and we'll paste that right there. And instead of k underscore down, we're going to need k underscore s. And the s is actually going to be lowercase. And then instead of changing player 2's y velocity, we're going to change player 1's y velocity. And then likewise, we'll change the up to a W, and then change the 2 to a 1. And now we have set the y velocities depending on what keys have been pressed by the users. However, the way that we have it set right now, if I just press the up arrow and let go of it, the character will just continue moving up indefinitely. And we need a way for the character to stop moving as soon as we stop pressing the button. And to do that, we're going to, just like we checked to see if there's a key down, we're going to check to see if a key has been moved up. So I'm going to copy all of this and skipping a line and pasting it right under there. I'll change key down to key up, and then I'm going to be setting everywhere it says speed, I'm just going to be changing that to 0. And then here where it says -1 times 0, we can get rid of that. Keeping it is also fine, but it just looks a little odd. So now basically, we're almost done with the controls. The last thing we have to do is actually call the move method, or the update speed method that we created earlier. So inside of every single iteration of the while loop, we're going to be calling p1 dot update speed, and then p2 dot update speed. And now when we press run, and I press the up arrow, player 2 moves up. If I press the down arrow, player 2 moves down. If I press W, player 1 moves up. And if I press S, player 1 moves down. So now we've got the controls. They work in sync. If I let go of them, they stop wherever they are, which is exactly what we needed. So now that we got the controls done, we're going to move on to adding the asteroids, or like rocks that are going to be flying across the screen, into the game. So I'm going to go ahead and create a new class called rock. So class rock, and this is also an object. And in here, what I'm going to do is also create another init function just like above. And for this function, we are not going to be having to pass in any variables, so we'll just say def init. And we're going to go ahead and create the variables. So let's go ahead and set the width and the height, which, since we have this asteroid sprite and it's 28 by 28, then the width and the height are also going to be 28 by 28 pixels. So we'll say self.w equals 28, and then self.h equals 28. So that looks good. Let's go ahead and create the image variable. So we'll say self.image is going to be equal to AST for asteroid, which is one of the things that we created up above. Next, what we're going to need to do is give them random X and Y positions, because we're going to be needing these asteroids to come in from either the right or left side and at anywhere between the top and the bottom of the screen. So to do that, we're going to use random, which we imported at the very beginning. As you can see, it's grayed out because we haven't used it yet. We're about to do so now. And the first thing we're going to do is say self.y is going to equal random.randint, which is going to give us a random integer between two values. And since we have the moons at the top, I don't want asteroids to come above that moon. I want them to be between the moon and between where the rockets start off in the game. So the moons stop at around 100. So we'll say between 108 and, as far as the smallest or the lowest position I want the asteroids to come in at, it's going to be like the screen height minus 200, because we just want like a little gap to be between where the rockets are and the lowest point the asteroids can be, and then minus self.h. So I'll just move them up a little bit more because we are setting the top position of the asteroids, not the bottom. So that's why we're going to subtract the height. So now that we have the Y position selected, we're going to go ahead and create like a small temporary dummy variable called randx, and we'll set this equal to just one of two values. We'll say random.choice. We're going to throw in a square bracket in here and say 0, 1. So it's going to pick either 0 or 1, and if it's 0, then the asteroid will come from the left side of the screen, and if it's 1, the asteroid will come from the right side of the screen. So we will say if randx is equal to 0, then we want to set the x position equal to negative 50 pixels minus self dot width, which is looking good. And if it is not 0, we want it to come from the right side of the screen, and we will set the x position equal to the screen width plus 50 pixels plus self dot width, which is looking fantastic. I guess we don't really need to add the width over here. That should be fine. And yeah, also, since some of them are going to be coming from the left and some are going to be coming from the right, the ones from the left are going to need a positive velocity to move from left to right, and the ones coming from the right are going to need a negative velocity to move from right to left. So we're going to go ahead and set those variables inside of this if statement block as well. So we will say if randx is 0 and it's coming from the left side, we want self.x velocity to be equal to a positive number. I think 2 should be fine for now. And then else self.x velocity should be equal to negative 2, so it can move in the opposite direction. That's going to wrap it up for the initialization function of the rock / asteroid. The next method we need to create is the draw method, just like up above. So we're going to say def draw. We're going to pass in a window, and we will say win.blitz to show it on the screen, self.image, which we initialized right here, comma, and then the x and y position of the image. So we'll say self.x, comma, self.y. That is looking fantastic. And then the last method we want to make is just called move. So define move. We don't pass in any variables, and we'll just say self.x is going to plus equals self.x velocity. And that's going to wrap it up for this class right here. And now that we have a class for the rocks, we're going to need to make a list that's going to hold all of the rocks inside of it. So right under where I created player 1 and player 2, I am going to go ahead and create a list called rocks, and we're going to set it equal to just empty square brackets. So now rocks is a list, but it has nothing inside of it. And I'm also going to go ahead and create one more variable called count. And this is going to be kind of like my own little timer that will be used to determine when we should add more rocks into the game so that we can make sure there's enough but not too many. And yeah, so we'll say count is going to equal 0 upon running the game. And now I'm going to scroll into the while loop, and what we're going to do in here is increment the value of count by 1 every single time we loop through the while loop. And then we're also going to check to see if the value of count is a multiple of any number we want, then that's when we're going to add more asteroids into the game. So for example, I can say if count percent or modulus 60 is equal to 0, so basically if count equals 60 or if it equals 120 or 180, any multiple of 60, then I'm going to add a new rock inside of the rocks list. So I'm going to say rocks.append a new rock. So that's how that works. And then after we do that, we're going to go ahead and create a loop that's going to go through the entire rocks list and do various things that we need done to the rocks. To do that, we're going to say for r in rocks, colon, we'll say, well, we're going to call the move function for it, so we'll say r.move. And then the next thing we need to do, well, let's keep it like that for now, and then we'll add on to it in a second. Let's just go up here. So the redraw game window, create another loop for the rocks, so we'll say for r in rocks, and we'll say r.draw. So now we can actually see them on the screen. Be sure to pass in window right there. And now I believe if we run this and we check out what's going on, we get a rock there, we get another one there, and they are just randomly coming in from both directions. And yeah, that's going to be like the obstacle of the game. We can mess around with the speed of these asteroids, and we can also change how frequently they come in. For example, right now, every 60 counts is when an asteroid comes. We can do one of two things. We can either copy this line and paste it, and now we're going to get 2 at a time instead of just 1 at a time. So as you can see now, we have twice as many asteroids. And we can also change the speed of how often they come in by making the number 60 something smaller. For example, if that was like 30, we're going to just get bombarded with asteroids. So now we just constantly have more and more coming into the screen, and it's going to be a lot more full. I personally feel like this is too many for us to be able to move across it without colliding with any of them, because that is the objective. We're trying to get Doge to the moon. So I'm going to go ahead and keep this at the number of 60, but I think I'm going to keep it to where we have 2 new rocks at every 60 counts. I feel like that's a good frequency, but you can always tweak with it, mess around with it, and make it exactly how you want it to be. Now that we have the rocks appearing on the screen, what I'm going to do is go inside of this for loop for all the rocks, and I'm actually going to delete or get rid of all of the asteroids that have already run their course. They've come from the left side and gone all the way across to the right side, and now they're off the screen, or vice versa. And I'm going to do this in order to just keep the list of rocks a bit more manageable. We don't want it to get too full, because then it's going to slow down the project itself. So what I'm going to do is check to see if it has a positive velocity, which means it's moving to the right, and it has moved completely past the right side of the screen. Then we're going to delete that asteroid. So we'll say if r.x velocity is greater than 0, which means it's positive, and r.x is greater than the screen width, which means it's completely moved off of the window, then we're going to say rocks, which is the name of the list, dot pop, and then in parentheses we're going to say rocks dot index of r. And so this line right here is responsible for getting it out of the list without making the program crash. And we're going to do this one more time for the other direction. So we can copy these 2 lines, and we'll say if r.x velocity is less than 0, and then r.x is less than negative r.width, which basically means if the x position is less than 0 minus the width of the asteroid, which is 28. So if it's less than negative 28, that means we can't see it anymore, and we no longer need it. So we will just say rocks.pop, rocks.index of r. And yeah, that is looking good. So now that we have the rocks inside the game, we have player, and they both move. We are going to start checking for collisions between the player and the asteroids. As you can see right now, if I run this and I move up the screen, it doesn't matter if any of these rocks hit us because we can just keep on going indefinitely. We can also even just go completely past the moon, which is not ideal, of course. What we want it to do is if we hit one of the rocks, then we want that rock to disappear and then the player to be dropped back down to the starting point. So to do that, I'm actually going to create a new class right here above player, and this class is just going to be called thing. Okay, it's going to be very, very short, and we're not going to pass anything in there. But what we're going to do is make this class a parent of player and rock so that we can just more efficiently check to see if we have collided. So we're going to create a function in here and say is collision, and we're going to pass in just another thing, right? So we're basically going to be calling this function from the players, and then each thing is going to be rock. So I guess we can just say rock. I mean, same difference, it does not really matter. And inside of this function, what we're going to say is if self.x is less than rock.x. Let me just actually change this to thing, because technically we would be able to call this from the rock and compare it to the player, or even between two rocks themselves. I feel like thing is just a little bit more arbitrary of a title. But yeah, so if self.x is less than thing.x plus thing.w and self.x plus self.width is greater than thing.x plus thing.w, then we're going to check the y position. So I know this line right here looks a little bit confusing, but just try to imagine what we're saying. We're basically checking the left point of self. So let's imagine where self is player and thing is rock. We're checking the left position of the player, and we're seeing if that is to the left of the rock's right position, and that the player's right position is to the right of the rock's right position. So basically they are overlapping from the left direction. Now we're going to check the y positioning. So we'll say if self.y is less than thing.y plus thing.h and self.y plus self.h is greater than thing.y. Whoops. If both of those are true, both these two lines are true, then what we need to do is return true, because that means there is a collision. And so this set of if statements right here checks if there's a collision from the left side. I'm just going to go ahead and copy these three lines and paste them right underneath, and we're going to check for collisions from the opposite direction. To do that, I'm going to say self.x plus self.w. I'm going to change this less than to a greater than sign and get rid of thing.w, and then say and. I'm going to get rid of the width, switch the direction of this to the right side, and get rid of thing.w. This is much shorter. And then the second line right here is actually going to stay identical because nothing changes in the vertical direction. And yeah, so now we have a method that checks to see if there's a collision from either side. If there is no collision, we're just going to go to the very end unindent out of these if statements and return false because the two objects are not colliding with each other. And like I said earlier, this class is actually going to be a parent of both the player and the rock classes. So instead of saying object here, I'm going to replace that with thing. And we're going to do the same thing for rock. We're going to say thing over there as well. And now we can actually call this function from either player or rock. It'll work for both of them. And so to do that, I'm going to move over here into the for loop that goes through all the rocks. And I'm going to say if p1 dot is collision, and I'm going to pass in r. That means they have collided. Then I'm going to get rid of that rock, right? Get rid of that asteroid. And I'm also going to reset the y position of that player. So since player 1 collided, I'm going to say player 1 dot y is going to equal the original y position, which is OGY. And then I'm going to copy these 3 lines, and I'm going to paste them for player 2. So we'll say if p2 dot is collision, then p2 dot y will get reset. And I think that's all we need inside of this for loop right here. So now if I run the project and we collide with one of the asteroids, that asteroid disappears and the player goes all the way back down to the bottom, which is looking very good. So since we have collisions now, we need to also check to see if the player has reached the very top to the moon so that we can give that player a point. So to do that, what we're going to do is check to see. We're going to just go ahead and create another function inside of the player class. So we'll say define like check increase score or something. That should be good. And in here, what we're going to do is say if like self.y is less than 100, so less than or equal to 100, that means they have reached almost the top of the screen, which is about where the moon is. And if that is true, we're going to increase the player's score by 1, and then we're going to reset the y position back to the original y that the player started off at. So we'll say self.y is going to equal OGY. So that's looking good. Now we just have to make sure we call this function inside of the while loop so that we're constantly checking to see if the player has reached the top. So just underneath where we update the speed, we'll say p1 dot check increase score, and then we'll say p2 dot check increase score. Sorry for using different notation. I'm kind of used to Java's camel case notation, but sometimes I remember that Python has like the underscores and everything's lowercase. I know it's a little bit ugly, but it still works, and that is all that really matters at the end of the day. So now let's go ahead and run this and see if we can get one of these guys up to the very top without colliding. This might take a little longer than I thought. Let's go up slowly. That's not good. I just want to verify that this is working. But it looks like we're moving a little bit too slow. So to change that, I'm just going to go up to the top and change speed to 3, and now we should be moving up the screen a whole lot faster. So now if I press the up arrow, we can shoot up to the top, and we go straight back to the bottom as soon as we hit the moon, which is perfect. And the next thing we have to do is actually show each player's score at the bottom so that we can know who is winning and who is losing. So to do that, it's going to be very, very simple. We're going to go scroll down until we find the redraw game window function. And inside of here is where we're going to actually display the scores of each player. So let me go under this for loop, and we're going to create a variable called font and set it equal to pygame.font.sysfont with capital S and F. And we're just going to use Arial. You can change the font if you would like to, and we'll give it a font size of around 50, and that should be good. Now we have to create 2 score texts variables that are going to be for each player respectively. So let's say p1 score text is going to be equal to font.render, and then we're going to convert the integer of the score to a string. So we'll say str parentheses p1.score, And then we are going to pass in a 1 here because we don't want to anti-alias it. And then we're going to pass in a tuple of 3 numbers, which is going to be the RGB value of the color we want the score to be. Now I'm going to pass in just 255, 255, 255, so that the score can be in white. We're going to copy this line, paste it right below, change the 2 to a 1, and change this to a 1 as well. So now we have 2 text variables, 1 for each player. And the last thing we have to do is actually throw them on the screen so we can keep track of each player's score. And to display it, all we're going to do is say win for window dot lit, please show on screen, and then the name of the thing we want to render, so P1 score text, and then comma, and then the X and Y positioning of each score. So I want them to be centered underneath each rocket. To do that, I'm going to add another pair of parentheses. I'm going to say 200 minus the width of this text variable divided by 2. So what does that mean? What does that look like? It's going to be P1 score text dot get width divided by 2. And then for the Y positioning, I think 740 should be good. It should be at the very bottom. I'm going to go ahead and copy this line, paste it right below, change player 1 to player 2 right here and there. And then instead of 200, we're going to say 600. So now it should be centered underneath each of the rockets. And if I run this, we should see 2 zeros right underneath each player. Now if I get one of them a point, so let's get this guy up there. Hopefully without colliding. Oh no. Try one more time right here. Come on, come on. Boom. So we reached the moon, and his score got incremented by 1. And that's pretty much all there is to this game, guys. So now all the functionality is working. The last thing that I want to do is simply add some background music so that the game can be a little bit more interesting. And to add the music to the game, as you guys saw in the very beginning, we already created that variable. Let me go ahead and uncomment those 2 lines and see what we're working with. So let's run this. And boom, we get the background music working flawlessly, guys. I'm gonna go ahead and drop a link to this song down in the description below. I believe this song is called Dogecoin to the Moon. I believe the song is by Flushes. I'm not entirely sure how to pronounce his name, but he's a great guy. Love the video, love the soundtrack. So if you guys want to check that out, click the link down in the description. And yeah, guys, that's all there really is to this game. Hopefully you guys found this tutorial very useful. Hopefully you guys learned something new. If there's anything I didn't cover, or if you have any questions about how this all works, just leave a comment down below in the comment section, and I will get back to you as soon as possible. If you enjoyed the video, if you liked the way I explained how to do it, and if it worked for you, be sure to give this video a huge thumbs up. It really helps more people find the video, find the channel. And yeah, if you guys are interested in programming, if you're interested in coding, making some games, some basic concepts, and just all around programming in general, be sure to subscribe to the channel and turn on post notifications. If you guys want to learn how to make some other games like Asteroids, how to make Pong, how to do like the Breakout game, I've got some tutorials on those as well. Be sure to check those out. And yeah, I think that's going to wrap it up. I'll see you guys next time. Peace.